Yes, today we are showing our prototype out in the water for the first time for guests. It's out there behind us. It's a 1:5 scale model. It's 5.5 meters long. It's 1 kilowatt output. The large one will be 38 meters long, times 7 times 4 meter, much larger, and giving 500 kilowatt. So we're having guests here, media is coming as well, and business associates and people interested in renewable energy. Many have an idea about wave power, how to get going or how to start with something. But it's important to see, does it have the right of life? So I set up some requirements before I decided to go for this. I said it has to be light, it has to be very strong, give high output, be based on few parts, simple parts and well-proven parts. Wave power gives energy when the wind is not blowing. And how can that be? Well, it's basic physics basically. First comes the sun, and the sun creates the heat. Heat creates the waves, the wind, and the wind creates the waves. But when the wind dissipates, after some days, the waves remains for many days. And in those days are when the spot prices are on the highest, and also the most fossils is burned through the whole world, because we need to power the systems. So by having wave power coming in the energy mix, by giving power when there are little wind and at night, you can have the best of all aspects. The wind power, sun power and wave power together is much better than just wind and sun by itself. Actually, the base load, when you combine wind power and wave power, base load is about 4 times higher. So the gaps are more smoothed out. So that's why wave power has a huge potential on all the coastlines of the world, on the west side basically. All is needed now because the climate problem is getting larger by the year. Right now asphalt is melting in India, and we have to do large investments and have the courage to go forward. And if we just continue on the present track with wind power and sun power as the main drivers, it won't be enough. Wave power is one of the major solutions going forward. And also because land is a scarce thing in many countries, like UK for instance, is all developed. But there's lots of sea out there. So wave power does not use any land area. It's out of size. It doesn't make any disturbing noise. It doesn't harm animal life. So that makes the potential for growth much larger. And also for the same ocean area, you can get 3 times more energy from wave power than from wind power. So we get basically more bang for the buck. The float is rectangular. Other systems are normally round. By having the same shape as the waves out here, even if these are very small, in rectangular shape you can lift 4 times more than just having the common normal round shape of floats. Using the hydraulic cylinder, which is connected to the seafloor, you can extract this power from the seafloor upwards. If it's just floating out there, cannot get this sort of energy out from every wave. So this combination of the large float, rectangular, and the hydraulic cylinder or actuator combined with the Pelton turbine, it is very unique. And our numbers show that the output and the cost is exactly what is needed. The system is validated through third-party simulations. I did that early on before I continued because I wanted to know that third parties get the same numbers as I do, or we do. Then I continued on with test rig runs, tank testing, offshore testing, and those tests have confirmed the simulations done by third party to the spot, to the point. Exact same numbers, I'll show you later on. Full scale, first one 500 kilowatt, later on 2 megawatt plus, and capacity factor 50%. This table on the left side shows on the yellow bars the simulation. On top you see the wave, and here comes the movement in the wave, like that. The red one is the test from the one out there. You see they are the same. It confirms that the test and the simulations are the same. It works as designed. Here's the movement, how it moves upwards in the waves, the speed meter per second. See again, it's the same. They are aligned on top of each other. So this does function as real life. Here comes the pressure, almost the same. There's a little bump on it because the waves out there are natural waves. They're not perfectly round, like in real life. Down here as well, here's the flow, the water going through the system, almost the same. Here's the power output also. You can see all these numbers. The test from real life offshore testing matches the simulations. And that's important because the next graph here is the 500 kilowatt. This is the full size. The same graph, same simulations, exactly the same thing. And what happens down here? You see 1 megawatt of power. This is before losses, because you have losses in the system of about 25%, and then you have some losses for regular waves. But this proves, by the testing here, this one, that the big baby will give 500 kilowatt in 4-meter waves. There is no doubt. This is a validation of the whole system.
It's working very well. We have met all the targets that we have. Our simulations are exactly matching, and the numerical models that we had are exactly matching what we see from the tests right now. So our plan is to now scale up to the full-scale, first full-scale pilot unit, which we plan to deploy in France in about 3 years' time, 3 to 3.5 years' time. So we have got the grant from the European Union, Senior Life, for doing that. And then later on we will test more and have more units in water in different regions to prove the technology to the 100% and reach the commercialization.
If I have a large shipyard coming along, large industrial company, large utility company with a global network, can all go faster for the good of the climate, because they have affiliates in all continents. And if you're a small company, we can perhaps build 50 ourselves per year. But if we have a large partner with us, we can build 200, 300, 400 per year. And for them also, it's meaningful. They're showing that they have green ambitions for real, not just talking about it. They have the chance to be green, to then show that outwards to the world, and also internally in the company they will have, let's say, positive spirit with the employees, showing that they do something sensible. They're taking a slight risk, yes, but the payoff might be huge in that way. In addition, given that I'm right, the market potential is billions and billions and billions in profit, just like wind power has been for many years. So for them there's a win-win-win, and also for us there's a win. So together we are stronger than just being on each side.
I think it was a very interesting day actually, and I think this technology has a great potential actually. And when I hear this utilization factor of 50%, which is almost comparable to offshore wind technique, I think is even more interesting. And especially also when I hear that a combination of this technology together with technology of sun cells and wind technique, offshore wind, and wave technique, because this type of energy is generated at different times. First comes the sun heats up the ground creates wind, and the wind creates wave. So I think these three technologies will compensate each other fully.
NoviOcean will be either the only one of the very few solutions that can make this breakthrough happen, then what you have just seen may be the dawn of a new energy area.